Okay, welcome to Unit 7, Coordinate Geometry. Just a reminder, throughout this video, you can pause whenever you need to. You can also adjust the playback speed if you're watching on YouTube so that I'm moving a little bit slower than I actually talk. So we are in our first path, which is translations. And we're going to check out this do now activity. Again, you should pause it here, do the activity on your own, and then unpause when you're ready to see my answer. If you feel like you've done this correctly, you can also fast forward through my answer to see if your answer matches mine at the end. All right, welcome back. It says look at the graph and find triangle XYZ. There it is. Start at point Y. Can you draw a new point that is 4 spaces to the right and 2 spaces up from point Y? So again, I'm at point Y. I'm going to count 1, 2, 3, 4 spaces to the right and 2 spaces up. I'm going to put a point there. Next, it tells us repeat the same process with point X. So again, I'm going to find point X. I'm going to go 4 spaces to the right and 2 spaces up, put a point there. And lastly, I'll repeat the same thing with point Z. 4 spaces to the right, 2 spaces up. I'm going to use my nice Notability straight line tool to make this into a really nice triangle. One interesting thing, we have a lasso feature. If you've done this right, your whole triangle should fit on top of the other one. And I'm going to put that triangle back though for now. So again, pause if you need to, but otherwise I'm going to move forward to the next slide, which is summarizing what we just did here. The process we just did was called a translation. Our original triangle XYZ is called a pre-image. So if you've probably learned in English class, the prefix pre means before. So that's our sort of before image. And the new triangle, though, isn't called a post image. They just call that an image. And we would name the new triangle. This is how we're going to pronounce it. Each apostrophe is prime. So this is going to be X prime, Y prime, Z prime. Right? So lastly, it tells us to go back to our do now and label our points X prime, Y prime, and Z prime. So if you remember, we started with Y to get here. So that's going to be Y prime. We started with Z to get here. That's going to be Z prime. And lastly, here I have X prime. All right, so again, pause if you need to. Otherwise, I'm moving forward. All right, so in this unit, we have 4 types of transformations we're going to learn. We're just going to introduce them today before we work on translations alone. So the only one where we change size is called the dilation. Right, the 3 that don't change size are reflections, rotations, and translations. So again, I'm going to sound like a broken record here. We're just trying to get people to get used to it. If I'm going too fast, pause whenever you need to, catch up, and then unpause, because otherwise it might feel like I'm going a little faster than I normally do in class. All right, so a dilation is a resizing of a figure so that it becomes bigger or smaller. Synonyms for dilations include, again, resizing, which I said up above, contraction, and that's typically when it becomes smaller, or expansion, and that's when it becomes bigger, typically. A dilation changes the size of the figure, but the angles stay the same. The new shapes and old shapes are not congruent, but similar. All right, so we talk a little bit about similarity in grade 9, but it's more something you're going to see in grade 10 here. So similar things share the same angles, but are different sizes. So a good example is anytime you have a model of something that's bigger or smaller, it's similar to the original object and not equal. So if your parents had a car and you had a toy version of the same car, those two items would look the same, but clearly one would be bigger or smaller. That's the essence of similarity. Okay, we are gonna look into reflections. So a reflection is a flip over a line called the line of symmetry. A point and its reflected point will be the same distance from the line of symmetry. So if you look at our example here, our line of symmetry is the x-axis, and each point is the same distance from its new point. So A is one space away from the line, as is A prime. B and B prime are both 4 spaces away from the line of symmetry. Synonyms for reflections include flip or mirror. Reflections do not change the size of the image. So I think it's pretty obvious that this triangle and this triangle are the same size. Our next transformation is a rotation. A rotation is a turn around a center. The distance from the point to the center remains the same. So for example, D, the center of our graph here is the origin. It is for many of the rotations we do. D and D prime would be the same distance from the center. Synonyms for a rotation include turn or orbit. Rotations do not change the size of the image. We spend a lot of time talking about synonyms in this part. This is because you might get a word problem that instead of saying rotation is going to say turn or orbit and so on. So a lot of times they'll switch you up with some new vocabulary, and you might be able to look back at these slides if you're stuck. Okay, the transformation we're going to talk about today is a translation, which is really just moving something without turning it or flipping it. So each point moves the same distance and same direction. And our synonyms for translations include slide or shift. And this is going to be the focus of this first learning path from Unit 7. Again, I'm going to move forward. You can pause it anytime. All right, so here it's telling us, one thing I like about translations is most of the problems use a very approachable, like English. Like these aren't math terms. Right and down, these are things you would say in the real world. So we're going to translate this pre-image 7 units right and 2 units down. All right, I'm going to do this with all 3 points, and we're counting spaces. So I'm going to start at the top. You could go alphabetically if you want. You could go in any order. And I'm going to go 1, 2, 3, 4, 5, 6, 7 to the right, and 2 units down. And that's where I'm going to put my new point. Do we call it R? Well, we actually call it R prime. Don't forget that apostrophe. And then repeat this process with the other 2 points. 1, 2, 3, 4, 5, 6, 7, and 2 down. And S, 1, 2, 3, 4, 5, 6, 7, 1, 2, down. Now, I only say this because this is feedback I get from students. I don't like to call any part of this year easy or hard. I think it's all within your reach. But I do have a lot of students who say that this is one of the more straightforward things we do this year. So if you think this feels easier than a typical problem in class, you're not crazy. You just know how to do it. Now, this is one way they will notate a translation. There is one other way, right? I think it looks a little scarier to students, but I promise you it's the same sort of activity we're doing. So I'm gonna show this in 2 different ways. So I'm gonna take my work area over here, and I'm gonna split it up into 2 sections. There's 2 good ways to do this. One is to remember that when you sort of shift your x terms, if you have x plus a number, all right, it's gonna move to the right. If you have x minus a number, it's gonna move to the left. If you have y plus a number, it's gonna move up. If you have y minus a number, it's gonna move down. So in this case, my x having a subtraction means it's gonna go left 3. And my y with a subtraction means it's gonna go down 1. So I can take each of these points and just go left 3 and down 1. All right, so that would give me j prime, left 3, down 1, that's I prime, left 3, down 1, H prime, left 3, down 1, K prime. Okay. So I do think most students like this method more than the second one I'm about to show you, but it is good to see both so that you can pick. All right, so the other method is I can write my images, or my pre-images original points. So I have HIJK, and I'm gonna find the coordinate pairs for each of these. So H is at 1, 1. I is at 0, 3. If you don't know how I'm finding these coordinate pairs, you might want to check in with your teacher. This is something you really need to have before doing this unit. J is at 3, 5. And K is at 3, 3. Now, I can find each of my new points algebraically also. So again, most people like the first method, but I'm showing you the second one as well. I know we're subtracting 3 from all of my x's. So if I subtract 3 from all of these numbers, I can write them over here. So 1 minus 3, negative 2. 0 minus 3, negative 3. 3 minus 3 is 0. 3 minus 3 is 0. And I know I'm subtracting 1 from all of my y values. So 1 minus 1 is 0. 3 minus 1 is 2. 5 minus 1 is 4. 3 minus 1 is 2. And if I try to plot these points now, guess where they're going to be? So negative 2, 0 is here. All right, it's going to match up with the points we plotted with this method. So negative 3, 2 is I prime. 0, 4 is J prime. And 0, 2 is K prime. All right, so those points will match up. Okay, so now is a great time to pause so that you can do the next 2 problems here. unpause when you're ready for the solutions. Okay, welcome back. I'm gonna take all 4 of my points, go 3 units left and 5 units up. So A prime ends up here, B prime ends up here, C prime 3 units left. So I'll just show in case you're struggling with spaces. 1, 2, 3, 1, 2, 3, 4, 5. And D prime 1, 2, 3, 1, 2, 3, 4, 5. This is a quadrilateral. So check your answer to mine. And I'm going to move to the second problem. Okay, so I'm going to show this problem both ways. First way, I know that -3 means left 3. And I know that y -3 means down 3. Okay, if you don't remember why, we have our examples up here. So I can just take all 4 of these points and go left 3 and down 3. So again, y is going to go left 3, down 3. W is going to go left 3, down 3. And V, same thing. My image here is a nice parallelogram, 2 sets of parallel lines. Now my second method is I could have found my original points. So X, Y, actually I should probably go alphabetical. V, W, X, Y. So V is at 3, 2. W is at 4, 4. X is at 2, 4. And Y is at 1, 2. So now I have to find V prime, W prime, X prime, Y prime. I like to start all my parentheses up. And I'm just going to take all 4 of my X terms and I am going to subtract 3 from all those. So 3 minus 3, 0. 4 minus 3 is 1. 2 minus 3 is -1. 1 minus 3 is -2. Then, again, so that was, my -3 came from there, but I have another -3 that I'm going to do to these 4 numbers. All right, so they're all going to go there. So 2 minus 3 is -1. 4 minus 3 is 1. 4 minus 3 is 1. 2 minus 3 is -1. Again, if I'm going way too fast, just pause. And lastly, I would graph these 4 points. But they're already there because I used the first method. But again, 0, -1, 1, 1. -1, +1. -2, -1. All right. So if you need more time, pause and rewind here. If not, you are going to open, you're going to click on this image, send it to Notability. There are 2 pages. If your teacher has not already posted the answers, reach out to them, let them know. You need to check your work when you finish. And when you're ready, you can unpause. Okay, if you've already done the pairs practice, you want to move on to IXL. So currently, these are the IXLs we should be ready to do. Some of you guys, this one really connects to what we just did. If you're struggling with this one, again, you might want to see the second half of this learning path before you jump in. You might be able to do this one already, but it is what we're about to do in this path. So again, unpause when you're ready to move on. Okay, so in the first part of this path, we were given a rule and we had to create a transformation. Here, they're going to give us a transformation and they want to see if we can write the rule. All right. I see one very common mistake on these problems, and that is students not understanding which is the pre-image or the image. So on these problems, you have to start at the pre-image. So find the one that doesn't have apostrophes. That's my original figure. So I'm gonna write that here. If you write these letters in a different order, it's usually okay, like S-T-U-R. I just choose alphabetical because I have to pick something. So that's what I use here. All right, it says start at point S. Explain how you could move from S to S prime. So we're just gonna use real plain English here. 1, 2, 3 to the right. And 1, 2, 3, 4 up. All right, and again, if you can't see that, all right, we're going 1, 2, 3 spaces to the right. We're going 1, 2, 3, 4 spaces up to go from S to S prime. All right, and that will actually work for any of the points from R to R prime, all right, from T to T prime, and so on. I'm not going to leave those there. I feel like it might look a little confusing, but it'll work for any of those 4 relationships. Now, we learned 2 ways up here. We learned sort of like this basic English way, and we learned notation with X and Y. So they want you to do the same thing here. So we can write a rule in a different way. I'm just going to say yes. Got to answer that question. What are the coordinates of point U? So they picked 1 point. My U is at 2, -1. My U prime is at 5, 3. So it says, how did the X and Y values change? So to go from 2 to 5, if someone told you, I want you to start with 2 and then end with 5, that means you're going to start with X and you're going to add 3 to it. All right, so 2 plus 3 is 5. And how did you go from -1 to 3? Right, well, I added 4. So my Y changes to Y plus 4. And again, you can witness this here. So we're going 3 to the right, 1, 2, 3, up, 1, 2, 3, 4. Okay, you should pause here and try these 2 slides and unpause when you're ready to see the answers. All right, we're doing the answers here, so I'm assuming you've unpaused. The original figure is HIJK. It's always the one without the parentheses. The apostrophes. It says start at point K. Explain how you would move to K prime. So I would go 1, 2, 3, 4, 5 left and up 2. So if you can't see that, just want to make sure everybody's getting the visual on this. Right, so we're going 5 left and up 2 to get from K to K prime. All right, they also want us to write it using the other notation. So point K is at 5, -1. K prime is at 0, 1. So if I had to go from 5 to 0, I'm subtracting 5. So that means x is going to go to x minus 5. To go from -1 to 1 means I added 2. So y is going to go to y plus 2. Okay. So we are moving to our pairs practice. So again, this is 2 pages. You need to open it, send it to Notability. If you want to check your answers and your teacher has not already posted them, please ask them to, and move on, unpause when you're ready. So now at this point, you should be able to do all 3 IXL activities. You can work on those to get the score you want, and unpause. Actually, you don't need to unpause. The last thing you can do is the exit ticket when you've completed the IXL. I'm not going to show the answers to the exit ticket because your teacher is going to want to be able to see whether or not you can do these 2 problems at this point. Thanks for listening.